Space, the vast and enigmatic frontier that stretches beyond our imagination. It's a realm where time itself bends, where cosmic winds carry secrets of creation, and where the unknown thrives at every corner. For centuries, humanity has gazed upward, captivated by the shimmering dance of distant stars, wondering what lies beyond. But space exploration has done more than just answer our questions. It has unleashed a flood of discoveries that challenge everything we thought we knew. From eerie sounds emanating from the void to phenomena that defy the very laws of physics, the journey into the cosmos is as strange as it is awe-inspiring. In this video, we're diving into the weird and wonderful side of space exploration, unraveling 20 of the most bizarre and mind-blowing facts that will not only leave you astonished but also redefine the way you see our universe. So buckle up as we embark on this cosmic journey. You won't believe what's waiting out there. Now turning to one of the strangest revelations from astronauts, the distinct smell of space. Yes, you heard that right, space has a scent, and it's as peculiar as it is intriguing. Those who have ventured beyond our atmosphere describe it as a mix of gunpowder, seared steak, and even hints of raspberries. But how can the vacuum of space, where no air exists to carry odors, have a smell? The answer lies in the interaction of high-energy particles with the materials of the spacecraft and spacesuits. When astronauts return to the safety of their spacecraft after a spacewalk, they often notice this unique aroma clinging to their suits. Scientists theorize that this scent is the result of polycyclic aromatic hydrocarbons, a type of molecule created in the high-energy environments of stars and interstellar space. These molecules can bond to surfaces and release a detectable odor when brought into a pressurized environment. This unexpected discovery not only adds a sensory dimension to our understanding of space, but also serves as a reminder of just how unusual the cosmos can be. And if you think smelling space is strange, wait until you hear about another surprising hazard astronauts face: moon dust. Stay tuned. As the next phase of this mystery unfolds, let's dive deeper into the origins of this enigmatic space smell. Renowned astronaut Chris Hadfield has vividly recounted his experiences, describing the scent as unforgettable, a mix of metallic tang and charred aromas that seem both alien and familiar. This peculiar smell sparks curiosity, leaving many to wonder what causes it. One prevailing theory points to molecular interactions in microgravity. When astronauts are exposed to the vacuum of space, even briefly during a spacewalk, high-energy particles, like those emitted by dying stars, collide with their gear. These particles trigger chemical reactions on the outer surfaces of spacesuits and spacecraft. In microgravity, these spaceborne molecules bond in ways that wouldn't happen on Earth. Once astronauts return to a pressurized environment, these molecules release aromas that our noses can detect. Another fascinating idea involves the remnants of stellar processes, as space is teeming with polycyclic aromatic hydrocarbons. These molecules are abundant in interstellar clouds and are thought to mimic the smoky, burnt scents reported by spacefarers. What makes this phenomenon so compelling is how it bridges the sensory gap between the infinite reaches of space and human perception. It is almost as if the cosmos leaves a subtle calling card, a whisper of its immense fiery origins. This smell, though fleeting, is an extraordinary reminder of the mysteries that linger in the void. And while the aroma of space captivates our imaginations, the physical challenges of lunar exploration present a far grittier reality. Moon dust, sharp and unyielding, poses dangers that go far beyond its deceptively soft appearance. Let's explore this next. Now turning to the rugged surface of the moon, let's uncover the unexpected peril hiding in its dust. Moon dust, or lunar regolith, is far from the soft, powdery substance you might imagine. This fine, gray material is jagged and abrasive, the result of billions of years of meteoroid impacts that have shattered rocks without the smoothing effects of wind or water erosion, which are common on Earth. Astronauts from the Apollo missions quickly realized just how troublesome moon dust could be. It clung relentlessly to their suits' tools and even found its way into the spacecraft. The jagged edges of the particles were sharp enough to weaken seals and scratch visors, creating potential risks for their equipment. More alarmingly, astronauts reported experiencing what they called lunar hay fever after breathing in dust that had been carried back inside. They described sneezing, nasal congestion, and throat irritation, with some even noting a peculiar smell, a mixture of burnt gunpowder and charcoal that added to its alien mystique. Scientists believe this scent could come from the oxidation of lunar particles when exposed to the oxygen-rich environment of the spacecraft. Yet, the dangers of moon dust go beyond its immediate irritations. If inhaled in significant amounts, these tiny, sharp particles could pose long-term health risks, potentially scarring lung tissue and causing respiratory issues. The hostile, clinging nature of moon dust serves as a stark reminder of the challenges faced by humans venturing into otherworldly terrain. And as future missions aim to return to the moon, dealing with this abrasive material remains a crucial problem to solve. But while we grapple with the gritty realities of lunar exploration, humanity's first attempts to communicate beyond our planet offered a much more poetic vision of who we are. Let's dive into the story of the Golden Record. As the next challenge unfolds, the issue of moon dust takes center stage in planning for future lunar colonies. This abrasive, clingy material is not just an annoyance, it's a formidable obstacle that engineers and scientists are racing to overcome. For long-term human presence on the moon, managing moon dust is critical for safeguarding both equipment and astronaut health. NASA and other space agencies are actively researching innovative ways to tackle this problem. One approach involves developing advanced coatings and materials for spacesuits and tools that repel dust, preventing it from clinging and causing damage. Another promising strategy is the use of electrostatic systems, designed to shake off or repel particles from surfaces using electric fields. These systems could help keep habitats, solar panels, and rover machinery free from the relentless grip of lunar regolith. Additionally, researchers are exploring concepts like magnetic filters and even self-cleaning spacesuits to reduce contamination. Future moon bases could also incorporate airlock designs specifically engineered to capture and remove dust before it enters living quarters, minimizing human exposure. NASA's Artemis program, which aims to return humans to the moon this decade, has placed a significant focus on these challenges. Collaborations with private companies and universities are driving the creation of cutting-edge solutions, ensuring astronauts can work and live safely on the lunar surface. The lessons learned from these efforts will not only support missions to the moon, but could also pave the way for addressing similar problems on Mars, where dust storms present an even greater challenge. As humanity prepares to embrace life beyond Earth, solving the riddle of moon dust is one small but essential step toward creating sustainable outposts in the cosmos. And speaking of bold steps, let's now uncover the incredible story of how humanity's message in a bottle was launched into the vast expanse of interstellar space on the Golden Record. Now turning to one of the most extraordinary artifacts of human imagination and ingenuity, the Golden Record, a cosmic time capsule sent aboard the Voyager spacecraft. In the late 1970s, NASA embarked on a mission not just to explore the outer planets, but to communicate the essence of humanity to any intelligent life that might one day encounter these voyages. The Golden Record was designed as a message in a bottle, carrying sounds, images, and other representations of life on Earth to tell our story to the cosmos. Crafted under the guidance of a committee led by famed astrophysicist Carl Sagan, the record contains an eclectic mix of content. There are greetings in 55 languages, showcasing the diversity of human culture. The sounds of Earth include everything from the murmurs of a baby to the rhythmic beat of a heart, as well as nature's symphony of wind, thunder, and whale song. Music was carefully selected to represent a range of cultures and traditions, classical compositions by Bach and Beethoven, alongside indigenous melodies and even Chuck Berry's rock and roll hit, Johnny B. Good. Beyond sounds, the record also features 116 images encoded in analog format, depicting human life, wildlife, landscapes, and scientific achievements. These images were chosen to illustrate not only who we are but also our capacity for curiosity and discovery. Mounted on the spacecraft, the golden-plated copper discs were engineered to endure the harsh conditions of space for billions of years. Instructions were also etched onto the records, designed to help any discoverers decode the contents and understand their origin. The creation of the golden record was a profound moment of reflection, a chance to consider what it means to be human and how we might be seen through the eyes of another civilization. It was a hopeful gesture, a reminder of our shared humanity and our dreams of making a connection with the unknown. But where are these cosmic messengers now? Let's delve into the ongoing journey of the Voyager spacecraft and their incredible odyssey through interstellar space. Now turning to the next chapter of the Voyager spacecraft's journey, these remarkable emissaries of humanity have traveled farther than any other human-made objects in history. Launched in 1977, Voyager 1 and Voyager 2 were originally designed to study the outer planets of our solar system. However, after completing their primary missions, they continued their voyage, venturing into the vastness of interstellar space. Voyager 1, currently over 15 billion miles from Earth, crossed the boundary known as the heliopause in 2012, officially entering interstellar space. Voyager 2 followed suit in 2018, providing humanity with its second set of direct measurements of this uncharted frontier. These spacecraft are still transmitting valuable data back to Earth, though the signals take more than 20 hours to reach us at the speed of light. Their instruments, some still operational after more than 40 years, are helping scientists understand the conditions of interstellar space, a region filled with plasma, cosmic rays, and magnetic fields beyond the influence of our Sun. The Voyager's journey through the cosmos is not just a technical achievement, it is a profound symbol of human curiosity and perseverance. Yet the question remains, will the golden records they carry ever be discovered by another civilization? The odds may seem astronomical. Space is unimaginably vast, and the Voyagers, though moving at incredible speeds, are tiny compared to the scale of the galaxy. However, the possibility, no matter how slim, is enough to spark wonder. Imagine a distant future, perhaps millions or even billions of years from now, when an intelligent species stumbles upon these records, deciphering the encoded greetings, images, and sounds of a long-gone Earth. The golden records are a message in a language that transcends time, distance, and culture, offering a glimpse into the heart of humanity. For now, these small spacecraft continue their silent, determined trek among the stars, embodying the spirit of exploration and the hope that our story might someday be shared with the cosmos. Moving forward, let's unravel the astonishing cost of the equipment that allows astronauts to thrive in such extreme environments, starting with the jaw-dropping price tag of a single spacesuit. Now turning to the awe-inspiring cost of space exploration, let's delve into the astonishing price tag of an astronaut spacesuit. Did you know that a single spacesuit comes with an estimated cost of $12 million? This mind-blowing figure makes sense when you consider what these suits are designed to accomplish. They are not just outfits, they are miniature spacecraft engineered to protect astronauts from the harshest conditions imaginable. Outer space is an environment of extremes, with temperatures swinging from scorching heat to bone-chilling cold, not to mention the lack of breathable air and relentless cosmic radiation. The materials used in a spacesuit are uniquely crafted to provide insulation, durability, and protection. For example, the outer layers are constructed from advanced fabrics like Kevlar and Teflon, which are resistant to micrometeoroid impacts, while the inner layers are tailored to regulate body temperature and maintain comfort. Beyond the materials, the technology integrated into each suit is groundbreaking. It includes a personal life support system which supplies oxygen, removes carbon dioxide, and even has a water-cooled temperature control system to keep astronauts comfortable during spacewalks. Then there's the intricate helmet, featuring a gold-coated visor to shield against harmful solar radiation while providing clear visuals of the surroundings. Every element, down to the gloves that allow for dexterity in gripping tools, is meticulously designed to ensure survival in an unforgiving environment. Building each suit requires extensive research, precise engineering, and rigorous testing to withstand the rigors of space. These towering costs highlight the extraordinary effort that goes into safeguarding human life in the vacuum of space. As impressive as these suits are, they are a testament to our ingenuity and determination to explore beyond the confines of our world. With this remarkable insight into spacesuits, let us now ignite our curiosity further by uncovering the bizarre and fascinating behavior of fire in zero gravity. Now turning to the fascinating and strange behavior of fire in zero gravity, prepare to be amazed. On Earth, fire rises upward as hot air creates a flow around it. But in space, where there is no gravity to cause this upward motion, fire behaves in a completely different way. Instead of the familiar flickering flames we see here, fire forms into mesmerizing spherical shapes, burning in all directions evenly. This happens because without gravity, the hot air does not rise, and the flame relies solely on the slow diffusion of oxygen to sustain itself. As a result, the combustion process becomes more stable and controlled, which has opened up a whole new world of scientific curiosity. Scientists at the National Aeronautics and Space Administration have seized this unique environment to study fire in microgravity, conducting experiments aboard the International Space Station. These studies are not just for curiosity, they serve a critical purpose. By understanding how fire behaves in microgravity, researchers can develop better fire safety measures for spacecraft and habitats, ensuring the safety of astronauts on long missions. But the implications of this research go beyond space missions. Insights into how flames burn more efficiently and cleanly in microgravity could revolutionize energy production technologies back on Earth. Imagine adapting what we learn from fire in space to create advancements in combustion engines or cleaner burning fuels. It is yet another example of how the challenges of space exploration lead to breakthroughs that benefit humanity as a whole. These surreal flames drifting silently in the vacuum of space remind us just how different and extraordinary the environment beyond our planet is. But hold on, this journey into the mysteries of space is far from over. Coming up next, let us dive into a truly peculiar experiment: why jellyfish were sent to space and what they revealed about life in zero gravity. Moving forward, let us delve deeper into the captivating research conducted aboard the International Space Station, where flames have been the subject of groundbreaking experiments. One particularly intriguing study is the flame extinguishment experiment, which focuses on how flames behave and extinguish in the absence of gravity. Researchers have observed that flames in microgravity burn at lower temperatures and produce less soot, offering unprecedented insights into the combustion process. This peculiar behavior has allowed scientists to explore innovative ways to create cleaner and more efficient energy solutions. Another experiment, known as the burning and suppression of solids experiment, examines how different materials ignite and burn in space-like conditions. The results have been crucial for designing fireproof materials and advanced fire suppression systems, ensuring astronaut safety in confined environments like spacecraft and space habitats. Beyond safety, these studies are paving the way for advancements in energy technology on Earth. By understanding how to optimize combustion in such a unique environment, we could revolutionize the way we produce energy, potentially leading to engines and fuel systems that are cleaner and more efficient. The mesmerizing sight of slowly burning spherical flames reveals the delicate balance of oxygen and fuel, a phenomenon that challenges everything we thought we knew about fire. These findings not only enhance our scientific knowledge, but also showcase the ingenuity of human exploration. As remarkable as these fiery experiments are, they are just one small piece of the puzzle. Up next, we will uncover the strange and unexpected outcomes of sending jellyfish to space, and how their journey unlocked surprising secrets about adapting to life beyond Earth. Now turning to one of the more peculiar experiments in the history of space exploration, let us talk about the fascinating journey of jellyfish in space. During the early 1990s, over 2,000 jellyfish polyps were sent aboard the Space Shuttle Columbia to investigate how microgravity affects their development and behavior. These jellyfish were chosen for their unique ability to sense gravity using specialized structures called statoliths. On Earth, these tiny structures help jellyfish maintain their orientation in water. But in the absence of gravity, scientists wanted to see how this sensory system would adapt and function. As the jellyfish matured and multiplied in microgravity, researchers observed significant changes in their statoliths, leading to impaired gravity sensing when they returned to Earth. The jellyfish that spent time in space struggled to orient themselves properly, suggesting that prolonged exposure to microgravity can disrupt biological mechanisms dependent on gravitational cues. This study not only revealed how space affects these simple creatures, but also has profound implications for humans. Just like the jellyfish, our bodies rely on gravity for key physiological processes. Our sense of balance, bone density, and muscle strength all depend on the constant pull of Earth's gravity. In space, human systems also experience challenges. Astronauts often report dizziness and difficulty standing upon returning to Earth due to how their inner ear systems adapt to weightlessness. By studying the jellyfish, scientists gained a better understanding of how microgravity impacts living organisms, helping them prepare for the effects of extended space travel on our own biology. So, while these jellyfish may have seemed unlikely astronauts, their journey provided vital clues about how life can and cannot adapt to the surreal environment of space. With this quirky experiment shedding light on human challenges in space, we now turn to a common misconception about the moon and why the so-called dark side is anything but dark. Moving forward, let us unravel one of the most enduring misconceptions about our celestial neighbor, the so-called dark side of the moon. Contrary to popular belief, there is no side of the moon that remains in perpetual darkness. The term dark side is a misnomer and actually refers to the far side of the moon, the hemisphere that faces away from Earth. Both sides of the moon receive equal sunlight as it completes its orbit around our planet. The far side experiences day and night cycles just like the near side, but because the moon is tidally locked to Earth, we only ever see one face of it from our vantage point. This natural locking has fueled the myth, leaving the far side shrouded in mystery for centuries. It was not until the advent of space exploration that we finally got a glimpse of what lies beyond the familiar lunar face. In 1959, the Soviet Luna 3 spacecraft was the first to capture images of the moon's far side, revealing a rugged and heavily cratered surface that was starkly different from the more familiar near side. Later missions, such as those carried out by NASA Apollo program, further demystified the far side, providing comprehensive surveys and insights into its geology. More recently, in 2019, a Chinese spacecraft made history by landing on the far side for the first time, opening up new possibilities for lunar research. Understanding the far side of the moon has been critical for advancing our knowledge of the moon's formation and evolution. For instance, scientists discovered that the far side has a thicker crust, likely due to uneven gravitational forces during the early days of the Earth-Moon system. This uneven development might hold clues about the history of our solar system itself. So, while the term dark side might sound mysterious and evocative, the truth is far more ordinary yet endlessly fascinating. The far side is not a realm of eternal darkness, but an integral part of our moon's dynamic existence. With this myth dispelled, our journey continues as we delve into a pressing issue that threatens the future of space exploration, space debris, and the growing challenge it presents. Now turning to the next challenge, space debris is becoming one of the most significant threats to the future of space exploration. Imagine this: every time a satellite is launched or a rocket stage is discarded, fragments of these missions are left behind, orbiting Earth at incredible speeds. These fragments, known as space debris or space junk, range from tiny paint flecks to defunct satellites the size of small cars. Despite their size, even the smallest pieces can travel at speeds exceeding 17,000 miles per hour, fast enough to cause catastrophic damage to active spacecraft or satellites. With thousands of objects currently orbiting our planet, the risk of collisions increases exponentially. This chain reaction of collisions, often referred to as the Kessler syndrome, could create a dense cloud of debris, making certain orbits unusable for generations. To combat this growing problem, space agencies like NASA and the European Space Agency have developed systems to track and monitor space debris. Using advanced radar and telescopic systems, they can predict potential collisions and maneuver active satellites out of harm's way. Additionally, new technologies are being developed to actively remove debris from orbit, such as nets, harpoons, and even magnetic capture systems. International collaboration is essential to address this issue, as space debris knows no borders. Governments and private companies are working together to implement guidelines for sustainable space operations, like ensuring satellites are deorbited safely at the end of their missions. While the challenge is immense, tackling space debris is crucial to preserving the future of space exploration. It is an issue that requires both innovative solutions and a collective commitment to maintaining the safety and sustainability of our orbital environment. With this pressing problem in mind, let us explore another fascinating phenomenon that arises in the unique conditions of space: the behavior of water and how it defies expectations in a zero-gravity environment. Now turning to the peculiar world of water in space, it behaves in ways that completely defy our everyday expectations on Earth. In the zero-gravity environment of space, water does not flow or fall as it does under the influence of gravity. Instead, it forms perfect, shimmering spheres held together by surface tension. This unique behavior is more than just a scientific curiosity. It has a profound impact on how astronauts manage hydration and even how they conduct experiments aboard spacecraft like the International Space Station. Imagine astronauts drinking water not from regular cups, but by sipping or capturing these free-floating droplets with their mouths, an experience that is both practical and incredibly entertaining to watch. Astronauts have also been known to play with water droplets, pushing and merging them together or adding food coloring to create mesmerizing orbs that appear almost magical as they float through the cabin. Beyond the fun, understanding water's behavior in microgravity is critical for life support systems. In space, water is carefully recycled and reused, and its unique properties in this environment help optimize storage and distribution for drinking, hygiene, and even oxygen production. These discoveries not only ensure the survival of astronauts on extended missions, but also inspire innovative water management technologies back on Earth. With its seemingly simple yet fascinating behavior, water continues to showcase the extraordinary adaptations required for life and exploration beyond our planet. Speaking of adaptations, let us now examine the emerging reality of space tourism and how it is bringing the dream of space travel closer to people like you and me. As the next phase of the journey into space unfolds, the concept of space tourism is no longer a distant dream but an emerging reality. Private companies like SpaceX and Blue Origin are at the forefront of this groundbreaking endeavor, making strides to open the cosmos to ordinary individuals. In recent years, we've witnessed historic milestones, including the first civilian astronauts embarking on journeys that were once reserved exclusively for highly trained professionals. In 2021, for instance, SpaceX's Inspiration 4 mission sent an all-civilian crew into orbit, where they spent 3 days circling the Earth. Similarly, Blue Origin has conducted several suborbital flights carrying civilians, including high-profile figures like famed actor William Shatner above the edge of Earth's atmosphere to experience a few unforgettable minutes of weightlessness. These flights mark a monumental step toward the democratization of space travel, with companies envisioning a future where commercial spaceflight becomes accessible to more people. Although the cost of a ticket remains steep today, advances in technology and growing competition could potentially lower prices over time, bringing this once unimaginable experience within reach for a broader audience. Imagine looking down at Earth from the vastness of space, seeing our planet as a fragile, breathtaking sphere suspended in the void, a perspective astronauts often describe as life-changing. This burgeoning industry is not just about tourism. It sets the stage for humanity's next giant leap, inspiring dreams of lunar vacations, orbital hotels, and even tourism on Mars. Space tourism is not merely a privilege of the few. It carries the potential to unite and inspire the entire human race by showing us our world in a way that transforms our understanding of our place in the universe. Moving forward, let us dive into an extraordinary celestial phenomenon, how the sun produces sound waves that allow scientists to listen to its fascinating solar symphony. Now turning to the fascinating relationship between sound and the sun, did you know that our sun produces sound waves? While these waves are completely inaudible to human ears because they cannot travel through the vacuum of space, scientists have found a groundbreaking way to listen to the sun. This incredible feat is achieved through a field of study known as helioseismology. Essentially, the sun's surface and interior are in constant motion, rippling with vibrations caused by turbulent convection and magnetic activity. These movements create pressure waves that resonate through the sun, much like sound waves traveling through a musical instrument. By studying these waves, scientists can convert the vibrations into measurable data and, in turn, record the sun's symphony. Think of it like deciphering the rhythmic pulse of a drumbeat but on a solar scale. Using observations from solar telescopes, such as the Solar and Heliospheric Observatory, researchers have mapped these vibrations to uncover intricate details about the sun's structure, including its mysterious internal layers and dynamic energy flows. Intriguingly, the data can even be transformed into audible frequencies, allowing us to hear these cosmic vibrations through modern technology. This research is not just a scientific curiosity. It's essential for understanding solar activity, such as sunspots, solar flares, and the powerful eruptions that release energy across the solar system. These phenomena can have a direct impact on Earth, affecting satellite operations, power grids, and even communication systems. By interpreting the sun's song, we gain valuable insight into its behavior and can better predict its impacts on our planet. This hidden melody of the sun reminds us that even in the immense silence of space, there are vibrant rhythms waiting to be discovered. Moving forward, let's explore a little-known phenomenon involving metals in space and how they can naturally fuse together in a process that might just surprise you. Now turning to the strange and unexpected behavior of metals in the vacuum of space. Did you know that metals can naturally fuse together without the application of heat or a welding machine? This process, known as cold welding, occurs because in the vacuum of space, there is no layer of oxidation or contamination typically found on Earth to separate the metal surfaces. When two clean, flat pieces of metal come into contact in this environment, their atoms can bond directly, almost as if they have become one continuous piece. This might sound like something out of science fiction, but it is a real challenge that engineers must consider when designing spacecraft and equipment. Cold welding was first discovered during early experiments in space and has since become a critical factor in understanding how materials behave beyond our atmosphere. For instance, if metal tools or parts unintentionally touch during a mission, they could permanently stick together, potentially causing operational issues. To counteract this, spacecraft are designed with coatings, lubricants, or other methods to minimize the risk of unwanted fusing. Interestingly, cold welding is not just a problem, it also represents an opportunity. Scientists and engineers are exploring how this phenomenon could be harnessed for future in space construction, such as assembling satellites or building large structures like space stations. Without the need for additional heat or complex machinery, cold welding could revolutionize how we create and repair equipment in orbit, making space missions more efficient and cost-effective. This peculiar property of metals in vacuum reminds us of the unique challenges and possibilities that await humanity in the realm of space exploration. With this in mind, let us dive into a remarkable experiment involving jellyfish and the surprising insights it has given us about life in microgravity. Moving forward, let us uncover one of the most persistent myths surrounding space exploration, the so-called space pen controversy. You may have heard the claim that the American Space Agency spent millions of dollars creating a pen that could write in zero gravity, while Russian cosmonauts simply used pencils. Although it makes for an amusing story, the reality is quite different. The truth is that both American astronauts and Russian cosmonauts initially relied on pencils during early missions. However, pencils in space presented their own set of problems. The graphite tips could break off and float in the microgravity environment, potentially damaging sensitive equipment or posing a hazard if inhaled. This led to the need for a safer alternative. Enter Paul Fisher, an inventor and entrepreneur who developed the Fisher Space Pen entirely with private funding. This ingenious pen contains a pressurized ink cartridge, allowing it to write in any orientation, even upside down, or in the absence of gravity. It can also endure extreme temperatures, from freezing cold to intense heat. Fisher offered his creation to NASA, which purchased the pens at a modest cost, far from the exaggerated claims of millions of dollars. The Russian space program also adopted the Fisher Space Pen shortly after. This clever innovation not only solved a practical problem, but also became a symbol of human ingenuity as we continue to adapt to the challenges of space exploration. By clearing up this myth, we see how creativity and determination often lead to solutions that benefit everyone involved. And as we move forward, let us explore how space exploration has revealed the mysterious power of bacteria adapting to life beyond Earth. Now turning to the fascinating world of microorganisms, let us delve into how bacteria transform in space. Interestingly, bacteria behave quite differently when exposed to the microgravity environment beyond our planet. Studies have shown that many types of bacteria become more resilient and virulent in space, meaning they can grow faster, form stronger biofilms, and sometimes even resist antibiotics more effectively than they would on Earth. This poses a unique challenge for astronauts and space agencies alike, as microorganisms that are typically harmless on Earth could potentially become hazardous in space. For example, the bacterium Salmonella, which is commonly associated with food poisoning, was found to grow more robustly aboard the space shuttle. This discovery raised important questions about how microorganisms might adapt and evolve in ways that we are only beginning to understand. To prevent the spread of potentially harmful bacteria across planets, rigorous sterilization protocols are implemented before any spacecraft leaves Earth. Space agencies like NASA and the European Space Agency take exhaustive measures to clean and sterilize spacecraft, ensuring that even the smallest traces of bacteria do not hitch a ride to other celestial bodies. This process, known as planetary protection, is just as much about protecting Earth from potential extraterrestrial microorganisms as it is about safeguarding other planets from Earth-based bacteria. By meticulously sterilizing spacecraft, scientists aim to maintain the pristine environments of places like Mars or Jupiter's moon Europa, where the search for alien life remains a top priority. The mystery of how bacteria adapt to space underscores the need for ongoing research, making it one of the most intriguing challenges of space exploration. Moving forward, let us explore the intense power of lightning storms on distant worlds like Jupiter, where nature's fury takes on an entirely new magnitude. Moving forward, let us venture into the mesmerizing and electrifying phenomenon of Jupiter's lightning storms, which are unlike anything we experience on Earth. Jupiter, the gas giant known for its colossal storms and swirling clouds, is home to lightning bolts that are both more powerful and more frequent than those on our planet. These lightning storms were observed in detail by NASA's Juno spacecraft, revealing that they peak in intensity near the planet's poles, a stark contrast to Earth's lightning, which tends to strike more frequently near the equator. Jupiter's immense lightning bolts can release energy that is many times greater than the most powerful lightning on Earth, creating a dramatic display that highlights the raw power of this distant world. Scientists believe that the unique atmospheric composition of Jupiter, dominated by hydrogen and helium, along with its powerful magnetic field, drives these extraordinary electrical storms. These findings not only deepen our understanding of Jupiter's turbulent atmosphere, but also provide crucial insights into how storms and weather behave on other planets, shedding light on the forces that shape our solar system. With such intense and awe-inspiring electrical activity, studying Jupiter's storms offers a glimpse into the dynamic and chaotic nature of the cosmos. From the wild storms of Jupiter, let us now focus on the growing complexity of managing Earth's own orbital neighborhood, as space debris becomes an increasingly pressing issue. As the next challenge unfolds, the issue of space traffic has emerged as a critical concern in our orbiting neighborhood. With thousands of satellites currently circling Earth and countless more planned for future deployment, the risk of collisions is becoming an ever-present threat. These satellites, along with fragments from defunct spacecraft and remnants of rocket launches, create a web of debris that poses a danger not only to active missions, but also to the long-term sustainability of space exploration. This growing congestion has prompted international space agencies and private companies to collaborate on innovative solutions to manage orbital traffic. One promising concept is the development of orbital highways, essentially designated lanes in space to streamline the movement of satellites and reduce the risk of impact. Automated navigation systems are also being explored, allowing satellites and spacecraft to communicate and adjust their trajectories autonomously, avoiding potential collisions with precision. Additionally, advanced tracking technologies such as ground-based radar and telescopes are ensuring continuous monitoring of orbital debris to provide real-time updates on potential hazards. These efforts underscore the urgent need for a cohesive international framework to address the space traffic problem, ensuring that our exploration of the cosmos remains safe and sustainable for generations to come. With the complexities of managing our crowded orbital environment in mind, let us now explore the fascinating behavior of water in space, a phenomenon unlike anything we see here on Earth. Moving forward, let us journey into the intriguing world of free-floating planets, often referred to as rogue planets. These are celestial bodies that defy the norm, drifting through the darkness of space without orbiting a star. Scientists believe that these planets may have been ejected from their original solar systems due to gravitational interactions or chaotic cosmic events, leaving them to wander the galaxy in solitude. Despite their isolation, they remain a fascinating subject of study, as astronomers have used sophisticated techniques such as gravitational microlensing to detect their presence. This method involves observing the way these planets bend light from distant stars as they pass in front of them, revealing their otherwise hidden existence. What makes these rogue planets even more captivating is the possibility that some of them could harbor life. While they lack the warmth of a nearby star, some may generate internal heat through radioactive decay or residual formation energy, potentially creating subsurface oceans beneath thick icy crusts. These hidden environments could mimic conditions found on moons like Europa or Enceladus in our own solar system, which are considered potential candidates for life. The discovery of free-floating planets challenges our understanding of planetary formation and the conditions necessary for life, opening the door to even more profound cosmic mysteries. As we ponder the secrets these lonely wanderers may hold, it is a stark reminder of how little we truly know about the vast and boundless universe we inhabit. As the next phase of the journey comes into view, let us explore an incredible physical transformation experienced by astronauts during their time in space. Without the constant pull of Earth's gravity, the human spine is free to elongate, and as a result, astronauts can grow up to 2 inches taller while living in microgravity. This fascinating phenomenon occurs because the discs between the vertebrae in the spine expand in the absence of gravitational compression. Essentially, the spine stretches out more than it would under the usual force of gravity on Earth. While this might sound like a pleasant bonus of space travel, it does come with its own set of challenges. This temporary height increase can lead to back pain and discomfort as the muscles and ligaments supporting the spine adjust to the change. Even more critical are the readjustments astronauts face when they return to Earth. Upon re-entry into Earth's gravity, their spines compress back to their normal length, which can sometimes cause further back pain and stiffness. Additionally, the lack of gravity also means they lose muscle strength and bone density over time, compounding the physical strain they endure during their mission and the rehabilitation period afterward. Scientists are actively studying these changes to better prepare astronauts for future long-duration missions, like those to Mars or beyond. By developing more effective countermeasures, such as specialized exercise regimens and equipment, space agencies aim to minimize these physical challenges and ensure astronauts maintain their health during and after their journeys into the vast unknown. As we marvel at how the human body adapts to the unique conditions of space, it is yet another testament to the resilience and ingenuity required for exploration beyond our home planet. Now turning to the broader health impacts of microgravity, the effects extend far beyond just the spine. One of the most significant challenges astronauts face during extended missions is muscle atrophy. In the absence of gravity, muscles that are typically used to support the body, such as those in the legs and back, are no longer needed to the same extent. As a result, these muscles begin to weaken and shrink from disuse. Similarly, the lack of mechanical stress on bones in microgravity leads to bone density loss at an alarming rate, with astronauts losing up to 1% of their bone mass per month. This is a rate comparable to, but far more rapid than, conditions like osteoporosis on Earth. These changes not only increase the risk of fractures, but also present serious recovery challenges when astronauts return to Earth's gravity. To mitigate these risks, space agencies have developed intensive exercise protocols to maintain physical strength and bone density on long-duration missions. On board the International Space Station, astronauts spend approximately 2 hours a day working out using specially designed equipment, such as resistance machines that mimic the effects of weightlifting in microgravity. Beyond exercise, researchers are also exploring medical interventions to combat these issues. Studies include the use of pharmacological treatments, like drugs to reduce bone loss, and nutritional strategies that optimize calcium and vitamin D intake. Furthermore, scientists are examining innovative technologies such as artificial gravity chambers to simulate Earth-like conditions and further protect the body. These efforts are crucial not only for safeguarding the health of astronauts on current missions, but also for paving the way for future interplanetary travel. The lessons learned from combating microgravity's effects extend beyond space exploration, contributing to advancements in medical research for conditions affecting millions here on Earth. And as we consider how these groundbreaking solutions continue to evolve, let us now explore how technology developed for space exploration finds its way into our everyday lives. Now turning to how space exploration has shaped our everyday lives, the technologies initially designed for the challenges of space have contributed to remarkable innovations on Earth. For instance, memory foam, originally developed to improve the comfort and safety of astronauts during rocket launches, is now widely used in mattresses, pillows, and even footwear, providing enhanced support and pressure relief. Another example is scratch-resistant lenses. This technology was first created to protect astronauts' helmet visors from damage in harsh space environments, but has since become a standard feature in everyday eyewear, offering durability and clarity for millions of people. And let us not forget the handheld vacuum cleaner. Designed for use on NASA, a spacecraft to collect samples of lunar dust, this lightweight, portable invention has revolutionized household cleaning, making it far more efficient and convenient. Beyond these well-known examples, space exploration has also driven advances in telecommunications, medical imaging, and weather prediction, affecting nearly every aspect of modern life. From the satellite systems that power our GPS navigation to the development of infrared thermometers, the ripple effects of space technology are profound and far-reaching. These innovations demonstrate how investing in the exploration of the cosmos not only expands our understanding of the universe, but also enriches life right here at home. And as we marvel at the ingenuity behind these everyday applications, let us now take a closer look at one of the more mysterious phenomena linked to the universe, the intriguing search for alien megastructures. With the next phase of the journey in sight, let us dive into one of the most captivating mysteries of the cosmos, the search for alien megastructures. Imagine a distant star suddenly dimming in ways that defy simple explanation. This is precisely what astronomers observed with the now famous Tabby star, a star located about 1,470 light-years away from Earth. The dimming pattern was irregular and inexplicable by typical celestial events like a planet passing in front of the star or the presence of dense interstellar dust. This bizarre behavior sparked a wave of curiosity and led to an extraordinary theory. Could the dimming be caused by an advanced alien civilization constructing something massive around the star? One speculative idea was the existence of a Dyson sphere, a hypothetical megastructure designed to capture a star's energy to power an advanced civilization's technologies. While no concrete evidence has surfaced to confirm such an ambitious notion, the concept has pushed the boundaries of our imagination and scientific inquiry. Scientists have since been meticulously observing these dimming phenomena with telescopes around the world, searching for clues that might reveal whether these anomalies are natural or artificial in origin. Although the search for alien megastructures remains shrouded in mystery, it serves as a reminder of how much we have yet to uncover about the universe. And as we ponder the possibilities of intelligent life beyond our planet, it also fuels the fundamental human drive to explore, to question, and to wonder about what else might be out there among the stars.